So let's say we have a cell membrane. This cell membrane has a pump, that is sodium, potassium, ATP is pump. This pump facilitates the active transport of sodium and potassium, that is opposite to the concentration gradient. It transfers 3 sodium ions from inside of the cell to outside of the cell and 2 potassium ions from outside of the cell to inside of the cell. As 2 positive ions are transferring from outside of the cell to inside of the cell and 3 positive ions are transferring from inside of the cell to outside of the cell. So there is an accumulation of positive charge on the outside of the cell and there is an accumulation of negative charge on the inside of the cell. So we say that the cell is polarized. Okay. Now, when the cell is in rest, generally there are channels present in the cell membrane which facilitate the diffusion, that is passive transport of ions. There are sodium channels and potassium channels. When the cell is at rest, the sodium channels are relatively very less active compared to potassium channels. That is, the potassium channels, the more number of potassium channels are active and less number of sodium channels are active. Okay. Generally in a cell in rest, when it is at rest, the potassium ion concentration in intracellular the potassium ion concentration inside of the cell is more and outside of the cell is less, and sodium ion concentration outside of the cell is more, inside of the cell is less. Okay. So by the law of diffusion, the potassium ion will move from inside of the cell to outside of the cell because there is a more potassium ion inside and less potassium ions outside. So in the starting, because of the law of diffusion, as the potassium channels are active and more potassium channels are active, potassium ions start flowing from inside of the cell to outside due to concentration gradient. As the potassium ions start flowing from inside to outside, slowly there is generation of negative charge in the inside and there is generation of positive charge on the outside. Okay. So this generated negative charge as an excessive negative charge, this opposes the flow of potassium ions, and this opposition, this force is called electrochemical gradient, or this is the force due to electrochemical gradient, and this force opposes the movement of potassium ions. Okay. And as there is an excessive amount of negative charge in the inside, the electrochemical gradient drives the potassium ions from outside to inside, and it opposes the movement of potassium from inside to outside. So this force is due to concentration gradient and this force is due to electrochemical gradient. The concentration gradient drives the potassium ions from inside to outside. Electrochemical gradient, because there is an excess of negative charge, potassium ions wants to move to this side because of ionic attraction. Electrochemical gradient drives the potassium from outside to inside. In the starting, concentration gradient will be higher than electrochemical. The force due to concentration gradient will be higher than electrochemical gradient. So the membrane becomes more polarized: negative, 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 positive, positive, positive. Negative on the inside, positive on the negative on the inside, positive on the outside. As it becomes more polarized, the electrochemical gradient will be increasing. At certain point, the force due to electrochemical gradient will be equal to the force due to concentration gradient. That means the number of potassium ions entering from inside to outside and the number of potassium ions moving from outside to inside will be equal. That is, there is an equilibrium to potassium ion, and when there is an equilibrium, the potential difference across the membrane for that particular ion is called equilibrium potential. Shabji.